Hi, and welcome to Prototype. We'll be solving the problem for LeetCode 200, number of islands. This is another problem in the LeetCode 75 study plan. Let's get to it. So given an m by n 2D binary grid, which represents a map of ones, and ones signify land, and zeros, which signify water, return the number of islands. And an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically, and specifically not diagonally. And you may assume all four edges of the grid are surrounded by water. In the first example, they give a grid with 4 rows, 5 columns, and it wants us to find the output 1. We can do that just visually by finding the boundary. We hit an island right away if we're going to start at the top left corner. So I0, J0, we find a 1. And how do we define the island? We keep traversing along until we find the boundary. So here at the 1, we can go down, down. And we're still at a 1, so we can down 1 more. Oh, okay, it's a 0. Let's go back. We can now try going to the right, etc., right, until we find the boundary. Basically, just draw around the ones. Okay. Example 2, there are 3 islands doing the same thing. One in the top left, one in the middle, and one in the bottom right. Again, because these ones connect only diagonally, they count as separate islands. They do not connect horizontally or vertically. Okay, let's get to it. So first thing is if the grid's length is 0, then we can just return 0 because we know there will be no islands if there is no landmass to check, I guess. Then we'll need a count, and this count initialized to 0, it will be keeping track of the number of islands that we find. Okay, and then as I said, let's just start in the top left corner. So we will need to traverse the whole grid. So we can do that with just some nested for loops here. So I++, and for let j equals 0, j less than any column, let's just say the first one, its length, j++. Then what are we going to do? We're trying to find the first island before we start looking around, checking the first island's surroundings. So if the grid I and j, the current row and column, if it is a 0, we found an island, we can increment the count, and then we need to start checking all the adjacent land masses. So let's say DFS. What are we going to DFS? Well, we're DFSing IJ. And here we'll need to do a couple of things. Let's create a helper function, call it out of bounds. It will take the current row and column, and simply we will just return if we are out of bounds. So if the row is less than 0, we're out of bounds, which counts as water. If the column is less than 0, the row is greater than or equal to the grid length, or if the column is greater than or equal to, again, the first row's column, let's just say, okay? Keep putting semicolons instead of the logical or. Okay, and let's create our DFS function. And let's say we call this starting row and starting column. And what does this refer to? It refers to the initial position that we found in our nested for loop. So again, we're going to walk through the whole grid, right, until we find a 1, and then we want to look for zeros. Okay, let's use a stack, and we initialize our stack with the things the state that we need to keep track. So the starting row and the starting column, and then we can just use a while loop. If the stack is not empty, then we're going to continue running, and we can just pop off the state that we're keeping track of, which is the current row column, stack.pop. Again, JavaScript doesn't have a stack object. We simulate it with this array. Okay, so we pop off the current landmass that we're checking, the current position, and we want to know is the row and column out of bounds. Okay, so call our helper function, pass in the current row and the current column. Okay, and then we also need to check, is it water? So is grid row column equal to 0? And if it is, then what we want to do is just continue, right? We're trying to mark off, we're trying to check for all the adjacent ones. So if it's a 0, or if we've visited it, okay, then we want to continue. Now, how do we want to mark the island, the land masses that we visit? Well, we could just do the current position, so grid row column, and then we can mark it off with something like an X, we can mark it off with a V for visited, or we can actually just mark it off as water. A little bit less clean, but then we only have to check for one thing, right? We don't have to check for another X. Okay, so we mark off the current position, and then we need to check up, down, left, right, right? All the adjacent pixels, let's call it. So then we just stack.push the state that we're keeping track of. So row +1, column, and then we will do this 4 times for all the adjacent edges. Row -1, and then the same for the columns. Stack.push, row, and then column +1, and one more. Okay. And that's it for the DFS. At the very end, we're just going to return the count. And we can run this. And it's accepted. Okay, let's just go over this one more time. Okay, so we start from the top left, and we're going to walk through the whole grid until we get to the bottom right. Okay, every time we walk to the next row column, then we're checking, is it a landmass? If we have found a landmass, great. We can increment our count +1, and then we need to eliminate, you could say, we need to check for all the adjacent lands that are attached to our initial point that found the 1. Okay, so we enter our DFS call. All right. Is the current position in our stack out of bounds? It won't be in the first case, of course. Is it a water, or have we visited it? Again, in the first instance, it's not, because we have specifically found a landmass. Okay, so it is not. So let's just mark it off. We visited it. We can just mark it off as water. Again, this could be an X. It doesn't really matter. And then we want to check for all the adjacent edges. So row +1, so we go down. Let's check up. Column +1, so to the right, and then column -1 to the left. And we're going to keep checking, right, until we fill out the whole island. And in this example here, we'll mark it off all as 0. After that's done, we're going to be back inside of our nested for loop. We're back at position I = 0 at J1. Okay, is this going to be a 1? It's not, because we marked off this whole island as 0, right? So move on, move on, move on, and then we're just going to keep running until we either find another island, in which case we're going to do this again, or we reach the end, and then our algorithm resolves. Okay, so submit. And there you go. So 60.3%, not the fastest. Let's just, for the heck of it, try submitting one more time with the exact same code and see what happens. Slower this time, so that's LeetCode for you. This solution shouldn't be any particularly slower than others anyway. But there we go. Okay, sorry. So that's the solution with DFS. Obviously, you could just switch this to a queue, and then you can change this to BFS as well. I like using the stack. Easy to keep track of mentally, and very similar to the solution for LeetCode 733 flood fill. All right, so that's it for this one. I do apologize for the bit of the hiatus there between now and the last video, but we're back on it and going to work through the rest of the LeetCode 75 study plan questions in short order. Subscribe to see more. Thank you, and see you next time.